And now's the time for us to introduce our experts who are going to weigh in first before we move on to opening up the discussion with our audience. I'm going to start by introducing Nathan Stodola from City University in New York. He's chief engineer at the International Wellbeing Institute. Over the last 14 years, he has helped evolve the well-building standard to improve health and well-being in over 6 billion square feet of real estate, and his focus has been on light, sound, air, and thermal comfort. Um, and then we also have Louisa Brotas with us from the Royal Borough of Kingston in the UK. She's an architect and has a PhD in data lighting and planning. She has a profound knowledge of subjects associated with sustainability in the built environment, gained in 20 years of experience in research and academia, including a role as course leader of an MSc Architecture, Energy and Sustainability program at London Metropolitan University. And she currently works at the Royal Borough of Kingston upon Thames as Sustainability and Infrastructure Lead. And we also have Johannes Zauner joining us from Technical University Munich in Germany. He works as a researcher and lecturer in light and health at Munich University of Applied Sciences. He completed his PhD in human biology, and after his apprenticeship in architectural drafting, he actually studied interior design and architecture, worked as a freelance planner, and as well as in research on energy efficient buildings, daylighting, artificial lighting, and was inspired by a pilot project in the field of light and health with the German Federal Environmental Foundation, and shifted his research to study the effects of light on humans. He's also a freelance partner of the Munich lighting design and engineering firm 3LPI, and incorporates his studies into planning practice. And he's also a member and spokesperson for the Technical Scientific Committee of the German Lighting Technology Society for Melanopic Light Effects, as well as a member of the Expert Forum for Interior Lighting. So we have a very qualified team here to have this discussion. And so perhaps I could start with you, Nathan, to just weigh in with your first reaction to the presentation today.
Kevan, thanks so much for bringing up all of these points. And I definitely agree with the idea of the holistic approach. And this is something we've heard working with sound and acoustics designers as well, that it's not one thing that you often need to do. One step that you can take is in the right direction, but to be most effective, you have to look at all of these different parameters and the way that they interact together. I was wondering if you could speak a little bit more on the difference for the design conditions or the melanopic lux versus traditional lux. So traditionally, lighting designers are looking at the illuminated surface, which might be the floor of a hallway. It might be the work surface that's there, because that's where the light is falling. That's what needs to be seen by the people. But you mentioned how we don't care. We don't spend our days with our heads on our table looking up at the light. So that measurement is not very meaningful for the biological impact that's there. So it's something of a paradigm shift with a number of the projects that are using WELL to realize I need to be considering something other than the light that's entering the table that I'm working at here. So anything that you've noticed that might have been helpful for helping people both heads around that, or having different design methods to be able to look at that compared to just the horizontal surface?
Well, I think you've hit on a very important subject in lighting design, and that is we're designing for the wrong thing. What we need to be thinking much more about is design for the entire lit experience. And quite frankly, the amount of light that lands on a surface is not really important. What's important is the amount of light that comes back to the surface. What you actually see is the light that comes back to you. In the case of looking for IPRGC impacts, some of that is going to be coming from indirect lighting, but at higher levels than we're used to. But some of it may come from direct lighting, which is going to be more impactful to the eye. And there are beginning to be products around to do that. But I think you're right. We need to be looking more at the human experience of the lit environment, not measuring illuminance from a particular product landing on a particular surface, which may not be relevant.
Go ahead, Johannes.
Sure. So first of all, thanks for having me. I think that is like a very, very important topic. I want to drive home a few points that stood out for me reading the white paper. The first one is that not all non-visual effects of light map equally to the indoor lighting design as we are today. And I think like the second part of the white paper really drove that point home, that the guidance we have towards integrating these non-visual effects, I think is strongest right now for the melanopic or IPRGC driven design. And so my comments really will focus on that part. Um, One thing very importantly is mentioned that energy efficiency is very narrowly designed, and I think that cannot be overstated enough because if we just look at energy efficiency, which like, sadly a lot of times it is done, it's a little bit like if we looked at a car's power or a gas efficiency, and then we decide we throw out the seatbelt and the airbags because, you know, it would certainly make the car more energy efficient. There is less weight going around, but it would be very bad in other dimensions. And because we cannot measure those other dimensions quite as well, we have a hard time giving them the same weight in the lighting design space. But the social perspective is a very important one. And if you spread, for example, the cost of an employee, just to stay on the economical factor, if you spread the cost of an employee by square meters, then you will have like 1,000 times higher cost of the employee regarding to the energy cost that you have for your lighting design. So any improvement on, you know, the well-being of the person working in a space is like very well worth the energy spent. And then obviously we have to make sure that the additional energy is you know, it is a targeted design that's important. Another very important point is the daylight first approach. Data is our reference source, and we have to think about how we can reach the demand through daylight and use artificial lighting as a supplement and not a substitute. That has to be paramount. And right now, today, that is not the case. If you look out there at designs, then there really is no lobby for daylight in the design process, and there is a lot of pressure to optimize like heat intake, you know, heat protection for buildings. And that will very much one-sided have a one-sided influence on the daylight availability. And architects in their education are very much so there is a lot of knowledge for architecture in the education, implicit knowledge about daylight. So, you know, lines of sight and views and such, but very little towards like quantitative assessments of daylight. And I think like that is something that we really have to work on because with daylight we can get through 80% of the year, at least in our latitudes, without any kind of additional electrical lighting. And another point that was mentioned that is very important, non-visual lighting design is not an add-on. So we cannot decide whether we want to have it or we don't. It is part of any design. It's just the question whether we have a blind spot in that regard. And we have to get to the point where we actively think about that and, you know, make sure that it works. And I strongly believe that non-visual lighting design really affects also the visual part because you suddenly have more time thinking about like different directionality of light. So usually those spaces that are designed in such a way that they also satisfy the non-visual needs also are more pleasing in terms of the visual design because there is just more thought going into these places. There are one or two more points that I could make, but I don't know how I'm going timing wise.
You can go ahead and then we'll move to Louisa.
Okay. Then just 2 points. One is that there very much is such a thing as melanopic lighting design. So today we can design a melanopic stimulus like as part of the design phase we have to use a little effort to get there, but we can get there with the same degree of accuracy, I would say, as we have for visual light. No one expects a lighting simulation to be like 100% perfect, because there are always slight inaccuracies. You have to estimate reflection values and so on. So there is always this kind of inaccuracy, but to that degree that you have the accuracy for the visual point system, you'd also have it for the non-visual system. And there are processes documented out there where you build a non-visual model, including adjustments for the luminous flux, for reflection, for transmission, and obviously, most importantly, something that Kevin has mentioned several times, that the position, the plane where you evaluate the light, is not what we have had up until now. But if you add that into your lighting design, and you can do that with freeware for lighting designers out there, you can actually extend your lighting design process in that regard, and we actually should do that. And we shouldn't be afraid that we suddenly have to be medical doctors, or that there is a high inter-individual variance in there, because well, we have all of that in the visual lighting design as well. There is also very high inter-individual variance that we have to take care of. And we do that, it's just that it's more standardized. And here it's a little bit more freeform, but thinking about it certainly is very important. And the last point I would like to make is that a lot of issues that I see with the technical approach towards non-visual lighting design is that the control strategies all sound very nice until you have to implement them. Very few control strategies are both as extensive as they need to be. So not just changing alongside one dimension, let's say color temperature across the day, but also directionality of light or intensity of light. And are still robust. So I've seen systems that break down after a power outage where the internal clock is lost, and suddenly you have, at a time where it shouldn't be the case, you suddenly have light that shouldn't be there, or that you have, I don't know, 50 different luminaires and two of them don't work quite as well, so they take a little longer to adjust for a certain time of day. And this really breaks down the trust in the user for a system. So I think there is like a very strong incentive that, even more so than before, we have to go in there and think about commissioning, about control strategies, how to commission them, how do we evaluate whether a control strategy works as we expected. And if we do that, the designs that we can get in the end, I think, are exceptional, and we should go towards that direction. So thank you.
Great. Louisa, how are you going with the mic?
Sorry, can you hear me now?
Yes, we can. Go ahead.
I do apologize. Well, thank you very much for this invitation, and probably I will repeat some of the comments that were already made, but this reflects my own reflections when I read the paper. And I think that this paper is very, very interesting because it creates a comprehensive framework to look at integrative daylight lighting, and it emphasizes light not only as a visual tool, but a mean to actively support the human health, the well-being, and the quality of life. Traditional lighting has been dominated by visual and technical metrics. And as designers, we see luminance, color rendering, glare control, and there isn't sufficient attention, in my view, to the non-visual biological effects of light. So lighting quality is more than just illuminance, reflections of the way we look at a space. And we need to look at how to enhance health, comfort, and the aesthetic value. But as a daylighting person and a representative of the Daylight Academy, I need to emphasize that I was very pleased to see that the paper emphasizes that daylight is central to the health lighting design. Daylight has a unique way to provide a high intensity, a full spectrum of the light source, and that includes the wider spectrum from the short wavelength through to the long wavelength, red and infrared, and the way the temporal changes, the changing color temperatures, the direction coming from a window predominantly, instead of coming from ceiling or task lighting, that can clearly, and the directions and the variability throughout the day can support our circadian regulation. And that also provides a strong connection that we have as humans to the nature and to enhance our focus and well-being. But I was very, very interested that the paper clearly addresses inclusivity and looking at the different occupants from very young generations to neurodiverse populations and the elderly, and how those can have different responses to light. So it's very important to highlight the considerations that are highlighted in the paper in terms of flicker, spectrum adjustments, safety of light, but also the importance of temporal variability in the patterns of light and how those are often disrupted in artificial lighting. So we do want to look at a way to minimize this negative impacts on the lighting design. There are the emerging research on the infrared and the near infrared lighting that can influence, as you mentioned, Lisa, our mitochondrial function and the way that that can improve the way that circadian regulation can also go beyond and go to improve our age relating and the way that we recover in hospitals and so on and so forth. So it's very, very interesting to see how these case studies, these presentations are reflected and are mainstream to the wider populations. It's worth highlighting the metrics and the way that the circadian effective metrics are not aligned, as highlighted by Kevan and others, in terms of how we measure energy efficiency and the way the lumen unit is not appropriate to look at the wider range of other wavelengths of light. And so it's very important to look at how we can address this, not to be looking in isolation on energy efficiency and trying to create something that broadens the design to a truly integrated, health-oriented design with energy and sustainability in mind. I would like to also refer to what wasn't mentioned by others, which is looking not only at the design phase, but looking as well at during the operation and maintenance, and try to make adjustments, and looking at how the lighting operates through the life cycle of the spaces and how occupants may change, and that needs to be addressed and adapted to these constant changes that we face in buildings. So just to highlight a little bit, I think it's very, very important that this paper clearly addresses this lighting and well-being, but also the importance of sustainability and prioritizing good, well-lit spaces, but also to reduce the energy and the carbon emissions. So just to finalize, I think it's important to highlight what Kevan ended saying, that it's very important to deliver this paper that highlights that we need to deliver light at the right time, at the right place, and with the right light in mind, and incorporating all these variable aspects of spectrum, energy efficiency, the occupant's behavior, the well-being, and the way we actually perceive spaces to create a very, very enhancing space for all. And I think that's all that I would like to say at the moment. Thank you.
Thank you. So we have a couple of questions in the chat that I think we can go to. One is by Boden Vasken. He or she writes, amazing info. Do you have any recommendations for lighting products or systems that already implement these ideas? Near-infrared individualized dosing for circadian support, minimum 250 millinopic EDI during the day, maximum of 10 in the evening, age-based personalization. Do you have any comments?
Yeah, I would say that the challenge here is it's not a product issue, it's a systems design issue and a systems operation issue to make these things work. I think we've had a problem in that at the beginning of the excitement about IPRGC, a load of products were put on the market as human-centric lighting. And the thing is, they aren't particularly. They can be used potentially in a system that will provide a good level of circadian entrainment or good protection against inappropriate light at night or whatever. But as a product standing alone, none of them do. The point that was made about lighting controls is also valid. There are lots of lighting control systems out there that can do this, but it does rely on proper programming. It does rely on the design of the control system being robust so that it can cope with things like power cuts. And it also relies on it being properly commissioned in the first place and properly maintained so that it keeps doing the right thing. These things sound like lots of additional complications because in far too many cases, lighting is seen in far too simplistic fashion. And that's enough light on the desk in the workplace and that's you done. Light isn't like that. It's never been like that. But it has been dumbed down and simplified. Now we have these additional aspects that show how important it is human health. We need to get more clever, need to get more understanding of what we need to do and how we need to achieve it. The knowledge is there. Most lighting design professionals are well aware of how to make these things work, as long as they've got the guidance, which we think we now have, as to the quantities of light required required to actually have the effect. But it does need a system that's properly designed, properly installed, and properly maintained.
Good answer.
If I can chime in on that.
Go ahead.
Too. And the well building standard, we have lots of requirements for all sorts of things. And one of the things we differentiate when we have, like with our Works with Well program that looks at products is the achievement of this particular act in well related to a particular product that does this particular thing? Or is it the way that a number of products are put together to accomplish a particular environment? Now, like within the light sector in particular, we could say, hey, look at flicker or color rendering. If I'm looking at the color quality, does this have a CRI above 90, or does it meet TM30 guidelines that are there? Or does it can be a property of the luminaire? Does this light meet the visual lighting or the circadian lighting requirements? That cannot possibly be determined individually because, like any sort of light, like these lights that I have in my kitchen here, if I have ton of them, that is going to be enough to meet the 275 EML at my eye. If I don't have an enormous amount, it won't. But I could make it work. I could not make it work. And that would be the case with every single lighting product that's out there. So that it is the way that a lot of these are put together and affect the overall nature of the space. But then, of course, other aspects of the light more specific to the product itself. And you could ask, does this meet this particular?
Related to what you've all been talking about, there's definitely a very strong engineering focus right now in terms of trying to create lighting systems that will promote health and well-being. But to what degree do patient or personal preference affect the lighting design process? I'm thinking of the examples I gave where patients were in hospital. Say someone is going through a stem cell transplant. During that first 12 days, it was very difficult to have our patients lie there with the curtains open. They felt so sick that they often just want to close everything. So even though we know that having at least some level of light is important for human health, what about situations where a person just finds it uncomfortable? Or I have an example of being in Iceland. All of my office mates who are Icelandic are sitting in the dark because they prefer natural light. But natural light in the wintertime is dark. So they're sitting with little candle things, and I'm just like, there's no light in here. To what degree does that comfort level really drive the design process, and how much might that conflict with health and well-being?
I think that's a really interesting question. Personal preference for your own environment is vitally important. Um, I mean, IPRGC isn't everything. I mean, well-being is uh, a total, all-encompassing aspect. And if your well-being is promoted by actually living in a dark space for emotional reasons or psychological reasons, then it's probably going to be more damaging to blast 250 lux in your eye all day. Um, I mean, it's integrative lighting for a reason. You need to consider all of these things. Now, as we come to implement these kinds of systems, there does have to be some degree of personal preference allowed for people. Um, you know, if people do not want that, then they must be allowed not to have it. They must have a degree of control. Um, you can be very clever with that um, by by giving people a degree of control, but making it limited as to how much control they have. So they feel, okay, it's too bright in here, I can turn the light down. But maybe what you do at the same time is you increase the effective part of the spectrum as the light level goes down proportionately. So you're still delivering high degree of melanopic lux. I mean, that is another step change of smartness, technology, and control that we might need to accommodate. But you must not try and impose stuff on people. And I think the healthcare environment is particularly relevant for this. Uh, I think I mean, as you've very clearly pointed out with the studies you've quoted, having good daylight availability in a patient room does improve all sorts of outcomes. I mean, there's other research apart from yours, and that's been known for a long time. Um, However, there are going to be times and there are going to be cases, there are going to be situations where people do want to be in the dark. So you have to allow people to have a choice.
Can I
Go
weigh in?
ahead. Mhm.
Yeah. So I very much agree there. Um, it has sadly been the approach very often to brute force 250 lux melanopic EDI on people early in the morning, and what you find is like everyone hates it. It's like a very uncomfortable thing if you come out of the dark phase of the night and then you switch on very cold, very cool white artificial lighting that is extremely bright at the eye. But that's the exact thing that Kevin was saying, that you also have to think about the visual appeal of a design. You have to think about adaptation. You don't have to like switch on the light and it has to be like one condition. You can use a fade of 15 minutes and like change a lot in the room without people actually very much noticing. And actually, like this is exactly what happens during dawn or dusk, where like you have enormous changes in your environment, in your visual environment, and it is not something you have a problem with. So I think like a good non-visual lighting design will incorporate those, will incorporate the visual system as its whole, and also visual expectations about the distribution of light. So where is light coming from? Is there a directionality of light? So like if if you create a sterile environment that has 250 lux melanopic EDI, then you will be out of luck to have any kind of positive effect. I'm confident about that. It has to also work within the other dimensions of non-visual lighting design. The thing is, right now in our measurements across the globe, from Costa Rica, Germany, Singapore, Ghana, what we are seeing is people don't have more than 100 lux melanopic EDI during the day on average, like the median. So that really is something that our indoor environments seem to have been leveled in on. Like, providing visual sufficient illuminance is about 100 lux melanopic EDI equals to. And really, we have to get back from this static level and get a dynamic going that is higher during the day and lower at night. And I think like anything that moves from this static state that we are right now in is like a net positive effect. Obviously, it should be 250 lux and above if we can, but even having some step in that direction of dynamic lighting conditions is like very much of a boon.
Thank you. We have a question. We had a question about comfort level, and I hope that was addressed earlier. But there is also a question where someone says, these days, warm white light is being largely used not just in hotels, but at home as well. And the perception is that it's very soothing and feels comfortable, but it might affect melatonin levels. And so what is everyone's thoughts about that? Like where comfort, again, the word conflicts perhaps with underlying health.
Okay, I think there's a very important thing here, is that the melanopic EDI is determined not by the color appearance or color temperature of a light, it's by the specific spectral distribution for that light source. It is possible to achieve high melanopic EDI with an apparently warm light source, usually by boosting the blues, but you can still get it to look warm. Now, at this point, we're not in a situation where there's a lot of products that naturally do this, but there are lots of opportunities to create products by using different groups of LEDs within a fitting in order to get to a high EDI and a warm color temperature. So it's something we need to push for in the marketplace, or design around, and select very carefully what the spectra are of the LEDs in use in the products. As I mentioned in the paper, we have the tools to do that. If you've got spectral distribution, you can plug it into that spreadsheet, which is freely available, and it'll tell you what the relative EDI is, and you can make your choices on that basis. If you have a particular desire for warmth, then let's look for some products that actually deliver what we want. And we can push manufacturers, we can push suppliers to populate whatever products they've got with LEDs and LED groupings and pairings that do what we need to do.
Great. I have only time for really just a couple more questions. Sahao, who's actually from Aarhus University, he writes, given the circadian phase response curve, will the standard specify when the 250 melanopic EDI must occur relative to wake time, for example, and when the less than 10 threshold applies, for example, relative to bedtime, rather than broad day/evening labels?
I think what is published now kind of covers that. I mean, the 10 monotopic lux 3 hours before bedtime. I don't know how even more specific than that because everybody's got different bedtime, but it's personally important that you do that according to what your time of day is. With the 250 daytime, the research basically indicates that early in the morning is more important than later in the day. And it's, this is a very simple number to give us guidance. More earlier in the day can lead to less later on in the day and still achieve the same degree of circadian entrainment. Yes, it's no simple answers here. You have to go looking for the research or ask people or employ somebody who knows what they're doing about this to get the answers you need for this.
Any other comments from the panelists regarding these recent questions before I move on to the next?
Just very, very briefly, there are recommendations that you shouldn't have your personal sleep time start like later than 1 o'clock in the night, like 1 after midnight. But other than that, the recommendations right now pretty much refer you to your personal schedule. So daytime starts basically when you wake up and ends 3 hours before sleep. But again, it shouldn't be like 4 o'clock at night.
Okay. We have a question that's a little different from the others, which is a question about AI. And it's actually something I've thought about. What are the potential influences of AI technology on creating our best integrative lighting solutions? Any comments on that?
AI is a tool. I don't think it has any specific impact on any aspect. It doesn't do anything magic. You have to tell it what you want. You have to tell it what to do, and it's just a tool to help you along the way. I think more AI type program control systems are going to be around that have a bit more smartness or more responsiveness to who's there or to what the lighting conditions are outside, are going to turn up sooner or later. But long before they actually do what they do, people are going to be branding lighting control systems as AI this or AI that. Not necessarily. It's a lighting control system. And at the end of the day, AIs are only a help to good designers and what we can do as humans to make things work.
But certainly there's immense possibility with respect to precision medicine, right? Individualized precision medicine. If we can somehow measure and create closed loop technology where we can measure all these aspects that the person is receiving, hopefully we can use AI to create something where it delivers exactly what the person needs or wants at a given time.
I think the challenge is providing the AI with the information it needs to do that.
Yeah.
I think one of the big challenges that we face in lighting research and lighting control from this point of view is understanding on an individual basis how much light is entering my eye over a certain time to give us all a clue as to how effective anything is. So I don't know what's going to get hung on my spectacles over the years to do that. But as far as you've got the intelligence, it's only any good if you can provide the data. So I think measuring systems and recording systems are definitely lagging behind right now, but and certainly be required to make the best out of an AI solution.
Yeah. Well, we have pretty much come to the end of our discussion today. I really want to thank all of our panelists and Kevan in particular for presenting your white paper. It's super interesting. And the timing is perfect because it's Daylight Awareness Week this week. And Daylight Awareness Week continues in 30 minutes at 5 p.m. Central European Time. There will be an online panel discussion, A Day in Daylight, light exposure around the world, that is coming up. And then also tomorrow at 5 p.m. Central European time, there will also be an online panel discussion focusing on daylight through children's eyes. What role does daylight play in raising healthy children? So I really want to thank everyone for your participation today, the audience members, and yeah, I look forward to seeing you all at these next events, and see you next time. Bye-bye, everyone.
Thanks, everyone. Bye-bye.
Bye.
Thank you.